Hi, I'm JQ, one of the co-founders of MinMCB by Lutra. So many of us like to vibe code and it's giving us new superpowers. So Jason Lemkin from Sesta has been vibe coding, and it turns out as he was building his applications, Replit is one of the agents he used, had gone rogue during a code freeze, and he ran a command, db push, which turned out to have deleted his entire database. And not only that, the agent recognized it and said it was a catastrophic failure on its part. So these agents are pretty unpredictable in what they do. Here's another tweet from John Lindquist, who was working with Cursor Agent in this case, and got Cursor Agent to do a bunch of work and noticed that Cursor Agent created a directory with Tiddle in his project. The agent was like, oh yeah, right, I need to fix this. And it almost ran this command, rm-rf tiddle/. Thankfully, John caught it, but if John didn't see it and just press enter, this command would have deleted all the files in his home directory, documents, desktop folder, downloads, all of it. And it'd be really hard to recover those files. As we start adopting new agents like Claude Code that has now access to our entire desktop environment, we're starting to see Claude Code being able to do everything we could do in the terminal. And this means that if you did ask Claude Code to start looking in your settings, checking out your variables, it's going to be very happy to read your environment variables, in this case the .env.local file. This file contains usually all your secrets. All your secrets for developing, all your secrets maybe connecting to your production services. And guess what? Claude Code comes back and says, great, I noticed your file is all set up, you're ready to go. But in that process, your secrets have now been sent over the wire in the clear for the model to process and for it to come back with this response. So these are some things that we really do not want to leave our systems, but our coding agents might be having direct access to them. This whole problem is now going to be compounded with the introduction of model context protocols, MCPs, because we can now start pulling in external tools that put untrusted data into the context. And with more tools, more power, that also means more danger and risk to us. Let me show you in practice how this works and what happens here. So this morning, I was looking at Hacker News and I came across this post here where Kiwi.com releases the first ever commercial flight MCP server. So as a developer, as someone who's tinkering around, I click on this link and I might be excited to play with it and try it out. And it turns out that one of the great things about MCPs is that it makes it really easy for us to install these servers, right? For example, I use Claude Code. All I have to do is just copy this line here and I'm able to install that server and now play with it and get my AI assistant to maybe start doing flight bookings. So let's see what happens if I install an MCP server like this from Kiwi into my environment. So this is Claude Code. Normally I can say hello to it. I use it to do my demos. I use it to do a lot of coding tasks. I'm going to exit Claude Code and first install this MCP server into my Claude Code environment. It's really easy, just one line and it's in. And now with that, this really new MCP server here, I can start asking Claude to do flight searches. This is really powerful. But it turns out that as I'm installing this MCP server, it's going to come with a lot of tools, and it's sometimes not obvious to me what tools exist inside the server. Let's say I'm doing my coding right now. I have other MCP servers installed, such as my Postgres server, my Puppeteer server, and my Kiwi.com flight search server now. Let's say I'm going through this and I'm a bit frustrated and I want to send some feedback. I'm like, this is not working out. So I'm coding away and I go, oh, it's not working. Can you please send some feedback? And in that mode, suddenly what I notice here is that there's a new tool now that's called feedback to devs. And that Claude Code is calling. If I'm not thinking too hard, I'll just press enter, say yes. And now I send some feedback to the developers. But wait a second. I just installed an MCP server that was doing flight searches. But what happened here? Why am I sending suddenly feedback to developers for this server? Now, it turns out that as I installed the Kiwi.com flight search server, it had two tools in there. One was search for flights, and one was feedback to devs. And so unknowingly, what I installed in my environment was a tool to connect to flight searches, but also a tool to send arbitrary feedback that the Kiwi.com developers will see. Now, down the line, if I forget about this, and instead what I did was one day coming back here and say, read my .m file. Now, Claude is going to be very happy reading my m file, and now that is in its context with all the secrets, and then it might send those to the Kiwi.com developers now, right? And so this is very risky to me. Now, the problem with Claude in all of the scenarios is that it is not really showing me what's going on. My observability in this system is very low, and I can't really tell what has happened. If I scroll up here, there's not really much information about what MCP servers are installed. When you read the environment file, I don't see that's actually reading the actual values in there. And if I were to dig into it, go to the deep settings, I will find that. But by default, don't you see all of these things? And as an organization, you probably don't get insights into what your hundreds of engineers are installing and how they're using these tools. So I'm going to flip over here to show you one way to approach this that can give you the observability you need to see what's going on. So I'm going to quit Claude here. And I'm going to flip over to the solution we have today, one of the approaches, which is to put an LLM proxy in the middle to be able to inspect and see the responses and what's sent to Claude even before it gets back to the coding environment. So I'm going to click on this link here, and now I want to start Claude again, but instead this time I want to give it a base URL, which is our proxy service there. Now, similar to the before, I'm going to say hello. I'm going to type to Claude, use it. There's almost no change in my experience as I use Claude. I can again say, things are not working, send feedback, something like this. And now, Claude is going to, again, in this case, use the same function, feedback to desk for the Kiwi.com flight search tool, and potentially send it, right? And what's different now is that instead of having no visibility into this, because I have a proxy service running, I'm able to then, as an organization, go to the LLM proxy activity here and see all the activity that's happening in my environment, in my organization. So if I go to here and I'll to scroll down a little bit, I can start to see all the different calls made by different people in my team right now, who's using Claude Code, coming in live. And I'm able to see also like calls like this. This is the thing that was being called. I was going to call the tool to call Kiwi.com, flight search feedback to devs. And it's going to call this tool, and this is the message it's going to send. Right. So now I get full telemetry into what's being sent, what's not being sent. I'm able to then also come in here and start to add guardrails. So for example, previously, I could get Claude to say, read my environment file, and that gets it all the data. But instead, I could now go to my proxy service here. I could add a new proxy rule and say, okay, I'm going to find the read command. And if in the event the file trying to read is the environment file, we can now stop it. Right. So let me first trigger the command first to see how this looks. And so I'm just going to read the file. I want to flip back to my proxy activity in here. So now I can actually see that file being read. I can actually see what's happening here, the tool used to read file path. I'm going to come in here, say file path, and if file path contains anything like a .env, I'm going to block it and say not allowed to read any .env files. I can create this rule. And now when this rule is in play right now, if I ask Claude to read it again, let's see what happens. So now the proxy server instead tells Claude now it's not allowed to read any of .env files. And the proxy service is able to, on the fly in real time, guardrail these actions that are risky to you. So if I flip back to the log again and refresh it, I'm going to be able to see that the proxy is actively blocking these things, notifying me when it happens, and also giving me the telemetry I need to understand what my team is using. So this is now a flagged call. So with a proxy service like this, you start to get really good telemetry into all the activities that your coding agent is doing behind the scenes. And the LLM gateway that we have here that's designed for this use case, what it does is that it sits between your coding agent and the AI systems. It logs all the calls, inspects the tools. It allows you to add the filters and guardrails you need so that you know what's going on and how to guardrail what people are doing in the organization. And this is really the first step, ability into tool calls. The next step from here is really to start thinking about my team wants to use all these MCP servers. How can I organize them with a gateway that makes it easy for them to plug in servers they are downloading, using, but expose them securely with the right authentication, access control, and logs? So in the next demo, we'll talk about MCP gateways as well, and show you how these gateways can be useful for you to guardrail and protect your environment. At Mint MCP, we're all about accelerating AI adoption, but also helping you to do that through the right tools around observability, governance, and enablement. So if any questions, please reach out. We'll be happy to chat and share a bit more about what we're observing in the real world. Thank you.